Good afternoon, everybody. Very welcome to our presentation, AI Agents That Work in Crypto. I'm Marco Bellini, Senior AI Architect from Bitcoin Suisse. I'm joined by Wolfgang Vitale, our crypto protocol experts. So AI has been the talk of the town since years. Everybody now is talking about agents and AI agents and crypto. We will present and quickly set the stage by showing how AI models are becoming more powerful, cheaper, how the AI IT stack, the software that enables agents is enabling new capabilities, how this is matched by the AI crypto economic frameworks that are enabling powerful primitives for a new agentic paradigm. However, there is still a missing piece. This is our thesis. We will unveil it in a few slides, but now let's set the stage and talk about AI models. I think nobody will be surprised. AI models are becoming more powerful and cheaper by the month. This is shown in this colorful picture. On the vertical axis, you can see the performance of AI models in chat arena. So the higher, the better the performance. And on the horizontal axis, you can see the price you pay for using an AI model in terms of US dollar per million of tokens. A token is roughly a word, technically more or less 70% of a word. So you can see that in a few months, the models are climbing to the upper corner where they become more powerful and cheaper. For example, the standard non-reasoning models are becoming a lot cheaper. You can buy now the same performance as 18 months ago for 1,000 times less. The reasoning models that enable more capability, they became 100 times cheaper in only 6 months. But this is not the full picture. As the models are becoming more capable, there is even more capability that is enabled by the IT, the software stack. So an AI model can have a conversation with you, but an AI agent can execute a task, can work independently for minutes, for hours, and perform what you ask. This is enabled by the software stack, for example, by the tool use. The MCP, the Model Context Protocol, allows the agent to browse the internet or to access a web server or a FTP server. Then you have additional software that provides functions such as memory, such as planning, and then you have other software that allows coordination between different agents. So what you get is an AI agent that can perform tasks, can use tools, is adaptable, can handle uncertainty and variability, and can perform useful tasks. For example, an AI agent can be asked by a user to book a trip to Cannes, and I wonder how many people in the audience used an AI agent for this. So this is enabled by connecting the AI model with the software stack, with the tool use, with browsing capability, the internet search, the planning capability. And of course, we have AI crypto frameworks that enable payments and management of identity, for example. And this can go even to more complex use cases, such as the one we saw this morning. So let's take a more complex task, make a business plan. This can be handled not by a single agent, but teams of agents. Just this morning, we saw a talk when there was a CEO agent, for example, a planner agent in the team that can orchestrate the work of different agents with different roles, like information search agent, or, for example, you can have a fact-checking agent, a summarization agent, a brainstorming agent, and so on. So you combine in a conversation, in a meeting between these agents, different skills through the specialization of agents, different viewpoints. This is a concept of agentic flow that allows a better performance than a single agent because you are synthesizing different viewpoints. And this can be brought to an even larger scale, ideally, of a single-person enterprise where a human would hire a CEO agent that will hire a management team of agents, and the head of marketing agent will hire their own team, and so on in a recursive way. So this builds complexity, of course. This creates opportunities in terms of what the agents can handle, but also potential pain points. If you're wondering how this may work in practice, we envision that there will be platforms, marketplaces, entry points, where the user can exchange their fiat or crypto, and they will get a service. They will detail their needs in a task, putting in guardrails and objectives, and they handle it off to a single agent or a team of agents. And of course, you may have a case in the future of an agent that is capable of hiring other agents on the same platform or on additional different platforms. And then you have a recursive hiring of agent, creating a complex structure of AI agent workers that is very capable, but also brings potential problems. So if the future holds AI agents that become your workforce, that are autonomous and then can hire each other, that can create this complex structure and hierarchies, they need to be managed. We need something more than this software stack, the IT stack that gives the tools, the memory, the planning, and the capability to the agents. We have a great support from the AI crypto economic stack, but we need an AI workforce management layer. This is our thesis. So basically what we need, like employees in your company need human resources, AI agents will need their own HR. So you need a layer that coordinates the agent and manages it. So we could call it artificial intelligence resources, but that's a mouthful, that's very long. Let's shorten it to AI-R, or even better, AIR. This is what we propose. AIR is a lens, a paradigm, but also a layer. It is a lens because it allows you to quickly draw from your experience, in your working experience as an employee, as an employer, as a freelancer, and see parallels between the human workplace and the AI workforce. So the cartoon is meant to be funny, of course. Here we have somebody, maybe an AI CEO, hired a team of agents, and hired also an AI agent who is a strategic management consulting agent. He gets his salary, but he's not adding a lot of value. He's just summarizing, paraphrasing, and injecting truisms. This is something we could envision that happens, that some agents are not capable, they're not earning their salary, by drawing parallels from the experience in work life, using AIR as a lens, as a paradigm. But there is more. AIR is also a layer, because we can speedrun all the decades of learning of HR, managing workers, finding what works, what doesn't work, using the best frameworks. So for example, let's talk about recruiting, which is defining the job for the agent, hiring the agent. So talking about capabilities, the best practice now in HR is strategic workforce planning, which means anything is expressed in terms of skills. So let's not talk about the role of the agent, let's talk about the skills of the agent, how to verify them and hire for them. Onboarding is also crucial. You have to onboard your AI agent to your non-AI system, like your Salesforce, your SAP, to your human employees and other AI systems. Performance is crucial, and we'll cover it in the next slide, because some of these tasks, they are not easily verifiable. And of course, you have to pay the agents and what to do when performance doesn't meet the expectation. This is where the AIR layer can help. So let's talk about performance. I just said that AI models are becoming more capable, that they code really well, for example. But coding is what we can call a verifiable output domain. So the code compiles or doesn't. It passes the test or doesn't. It passes the quality criteria and the metrics or it doesn't. So it's possible to compute the error and score the result so that the AI model will learn from it. But there are some domains like tax preparation, business planning, crisis management, where the output is not so verifiable. You need a human expert to assess it. It's not that it will automatically be scored by any AI so that it can learn. The data also in this field is scarce, it's difficult to come by. And of course, crypto can help can bring some solutions, like, for example, incentives to data markets for this data that is scarce, rewards for subject matter experts that share their knowledge with AI, so that we can get better AI models for these domains as well. So it's a task, like in the illustration, it's cutting, but cutting can mean laser etching, which is programmable, is very precise. It's very easy to see your output versus your input and check where the errors are and to improve. But it could be also chiseling. It could be producing an art form, and how to score that and to improve on that is not a given. And this brings to the crucial point of performance and reward. So there is something called the law of nines. So if you have a sequence of steps in your workflow that needs 10 different steps, 10 different agents, and they all depend on each other in a sequence, a performance of each agent at 90% is not enough, because your overall performance on average will be much lower. Of course, you could say, okay, but I'll throw just more agents. Each step will be done by 100 agents, so I could potentially solve that. That will work easily, only if there is, for example, like a binary outcome, a voting, then is possible. But if you have to vote on a business plan, that gets a bit more complex. Of course, this also works well when everything is statistically uncorrelated, which is debatable. So what I'm saying is, autonomy of agents is a great thing. It unlocks a lot of opportunities. Then, of course, you have agents that are honest, that will not steal your cryptos. That's great, but they need also to perform at the appropriate level. And of course, when you have a complex sequence of 10 agents, one makes a mistake, the outcome is not good anymore, but the other 9 agents did not make a mistake. How do you share rewards? You need a policy for that. So let's also open the door to a minefield, potentially, of compliance, everybody's favorite topic. Because we have talked about AI agents that are extremely capable of hiring other agents, of creating this complex hierarchy, of delegating tasks and subcontracting tasks. What happens in the compliance world when you have this kind of situation, like we showed in the beginning? So GDPR mandates, for example, when you deal with personal data, you have a data controller, which is a natural or legal person who has the means and the purpose to determine the usage of personal data. Now, if you have AI agents that hire each other and delegate tasks to each other, you have a situation of probably shared controllership. According to GDPR, you have to recognize it and disclose it. If you don't do that, there are potential liabilities and fines, of course. Then you have, of course, processing of data across this stream of agents that could cross geographical boundaries in different countries, which could trigger data transfer and data processing across border. And this has also legal implications. So what I'm saying is there are a complexity of issues that can be unlocked when you reach this stage of extremely independent and autonomous agents that can create a structure of large complexity. There are, of course, benefits from the crypto economic frameworks. They can provide primitives such as immutable logging. This is great for auditing and for traceability. But this is not enough. For example, the European Union Artificial Intelligence Act mandates also explainability, which is not the same as logging. So in a summary, we see that this enormous potential of autonomous agents that collaborate in each other, but when the complexity will cross some thresholds, we need to have more than autonomy. And we need to build this error layer. I will pass now to Wolfgang, which is going to explore the risk and the opportunities.
Thank you, Marco. So let's start from summarizing the story so far. Basically, we applied functions from HR functions to agents, resulting in 4 pillars: recruitment, onboarding, performance, and rewards. And by the way, we didn't include yet learning and development because maybe agents are not ready yet to start a career and growth, but we will see. That will be the natural, extension of the model. But let's get back to the model now with the 4 pillars and try to apply it. I say that the model is a layer and a lens. It's a layer because it tells us what to build, or it's at least guidance on what to build, inspiration. And I think it's clear by now, after everything that Marco explained, that if you want to enable a new economy with billions of agents that act independently and create independently complex work relationship, maybe there is some more work to do. Yeah, I would say there is a lot of work to do, but we also have good news, because we are not starting from zero. First good news, we are not starting from zero. The model is also a lens that we can use to learn from HR. Yes, basically, if you know where to look, you will find at least inspiration on how to handle these challenges. And number 2 of good news, crypto is actually very well positioned to be a good match here and provide what we need for managing the agentic workforce. And I will summarize these with the properties of verifiable performance, audible compliance, and economic alignment. So that was the summary. Let's go one level deeper and see what we can actually do, in practice, what we can actually build with crypto. And I see here different approaches, but I'm open to everything, of course. And all these approaches are like, they have different levels of proximity and commitment to the model, if you will. Like, if you want, you can go all in and start building the whole stack, building the whole layer, work on the whole layer, and position your product as the workforce management layer for AI. Or you can be more specific, depending on your experience and interests, and attack maybe only one of those verticals. Starting with recruitment, you can build job marketplaces. You can build reputation systems based on reliable skills, and skills that are actually backed by a proven track record. That would be great. Or you can work on onboarding, building frameworks for authorization controls and delegation to agents and in between agents. You can work on another vertical that is performance, of course, very important. And here you can build mechanisms for distributed evaluation or for tracking performance history. Both of these are extremely important, especially for non-verifiable output domains, as explained by Marco. And the last vertical I mentioned here is rewards. And in this case, you will build mechanisms for distributing and allocating rewards that are actually dependent on how much the agent, actually contributed to the job, and mechanisms to keep the agents accountable. So rewards, but also, penalties if needed. That would be the second approach. The third approach, of course, you can build outside the model while still being aware of what are the challenges that we discussed. So I would say that any project contributing to these properties of verifiable performance, auditable compliance, and economic alignment would, of course, be very well aligned with the efforts we are describing here. I'm talking about projects, for instance, working on programmable staking or on oracles, dispute resolution mechanisms, CKML, and so on, you name it. All of these will still contribute to enabling agents that work effectively and compliantly. So I will conclude here our talk with the last slide. I think one of our main messages here for the builders and the broader community is that, obviously, of course, autonomy is extremely important. An agent is not an autonomous agent. Is it even an agent? And of course, it's extremely important that autonomy is something that you can prove and verify. It's not like, trust me that I act independently, there is no human in the loop. Of course, that's important, but I don't see that as an end goal, but rather as a starting point. Once you have all these agents that actually act independently and are free to open new complex work relationships that can really escalate in a way that you cannot predict as the original human, well, then there is a lot of other problems that arise, and we believe that the AIR model will provide the guidance as a layer on what to build, or at least inspiration and guidance on what to build. The AIR model is also a lens in the sense that it allows you to learn from HR, transfer best practices from HR, starting from what we know worked and maybe still works for the human workforce and apply it to the agentic workforce, directly or adapting it. So that helps a lot, of course. Now, if any of these topics is of interest to you, please reach out after the presentation here or online. We're always open to discuss more about these. We can talk about how to better formalize the model. I would say this is a starting point. We can talk about practical applications, what makes sense to build based on this layer, what it doesn't, and what is maybe already out there and we can put together in the model. But in any case, please connect, let's talk, let's discuss, and build on top of the AIR model together. Thank you. Mm-hmm. We have a question in the back.
For recording, yeah, I will take it back. Wait.
Thank you very much for the presentation. How do you use all this inside your company?
So this presentation was focused on the outside world, of course, from platforms, but I think there is learning lessons that can be transferred also on building your own solution within. So the hiring is different. Obviously, you choose the models. You have to select the models that have the appropriate performance and price. The onboarding, I think, is more crucial here because if AI interacts with your employees, you want to have smooth interfaces, smooth handover of the processes between your employees and your AI workloads. So you have to find the good solution that works. Also because your human workforce, not everybody is an expert at using AI. Then, of course, performance means your evals, which is absolutely crucial. Rewards is probably not applicable so much in this context. But I think this is something to keep in mind when you develop also inside your company, your ecosystem.
So we don't have any time for another question, so thank you again, Mr. Speakers.